Hi, welcome to the pre-calculus lecture series. And in this video, we're going to go over the chapter 3 practice test. Okay, so remember chapter 3 we're doing is polynomial and rational functions. Okay, so let's go to our practice test to see what type of the problems we need to know how to do. Okay, so this is the okay, so here, let's start here. Okay, so it said consider the following rational functions here. Which of these rational function has a horizontal asymptote? Okay, so the first one we are looking for the horizontal asymptote. Horizontal asymptote, that means when the x approach to infinity or negative infinity, and to see the limit exists, right? So in here, we talk about that, the horizontal asymptote, you compare the degrees of a polynomial on the numerator and the denominators, right? So if the numerator is bigger than the denominator, then horizontal asymptote do not exist. If numerator equal to the denominator, then the horizontal asymptote will be the ratio of the two leading coefficients. If the numerator is less than denominator, then it's 0, so it exists. So let's take a look at the first one. The Rx is 2x minus 1, x squared. So here, this is the first degree, this second degree. So the limit is approached to 0. So we say, yes, Rx exists. So the horizontal asymptote is fine. And then the Sx, so we have x cubed and the denominator is x squared. So we know the horizontal asymptote does not exist. The same is tx. How about ux? Ux here is a square and the squares, right? So I know the ux, the horizontal asymptote exists, is equal to 1. Then take a look at wx. Wx, the top is bigger than the bottom, so horizontal is not exist. Okay, so the next things here, we talk about the slant asymptote. The slant asymptote basically will tell you is if the numerator degrees is bigger than the denominator degree, and then you can use the long divisions, or you can use like the synthetic divisions to find it. So like it's like will be like the x, like you will have some function plus, the remainders, right? So for here, we have the slant asymptotes here. So the Sx is here. This is the slant asymptote exists here, okay? So for the Tx is here, right? So your slant asymptote exists, but it's not a line anymore because after divided, it will be x squares, right? So, but still it's a slant asymptote. So I know the Tx exists. The same is what? The same is Wx because the numerator, because the numerator degree is bigger than the denominator degrees here. Okay, so then the next ones here, we say which one has no vertical asymptote? No vertical asymptote. We know the vertical asymptote is where the denominator going to be 0. So the first ones here, you can factor, right? So this one you can factor. This is x minus 2, x plus 1. So this ones here, we do have vertical asymptote. This one we have, this one we have, this one we have. The only one we don't have is this one, it's x squared plus 4, so it's Sx. The reason why there's no vertical asymptote, because this number is always greater than 0. There's no such value will make the denominator equal to 0, right? So there's no vertical asymptote. Okay, so then the next ones here say which function has a hole? Okay, so remember what is the whole? That means the wholes here, right? The wholes here will be what? The whole will be like after you factor, you'll be able to cancel out. Okay, so these ones here, we factor, nothing we can cancel. This one we can factor the x, and this will be x squared minus 9. Then if you continue factor, this one will be x minus 3, x plus 3, Okay, so this is x plus 2. Nothing you can cancel, so there's no whole here. Okay, so how about the ux here? The ux, the top one, I can factor is like is 2 3s, right? So I can say x plus 3, x minus 2. So this is x minus 5, x plus 5. Nothing you can cancel, right? So there's no whole here. So this one, I factor the x out. This is x squared plus 6x plus 9. So this one you can factor is x plus 3 to the square. Oh, I have x plus 3 on the bottom. I can cancel 1. So this one has a holes here, right? So which one has a holes here? Is wx here. Okay, so now the other things here we say, what is the asymptote for the function Rx? Okay, so we just say the horizontal asymptote from the first one we say is because the denominator degree is bigger than the numerator. So horizontal asymptote is y equal to 0. Then we have the vertical asymptote is the denominator, right? So it's the denominator equal to 0. So what are the denominator equal to 0 is will be x equal to 2 and x equal to negative 1, right? So those are the asymptotes. So it's very important, right? So we understand the different asymptotes here. Okay, now let's take a look. Use the long division or synthetic division to find the quotient and the remainders. So like we said, synthetic is a kind of easier than long division, but it's not a flexible. So typical, I will use the synthetic, if my denominator, okay, so if my denominator here is just like the x is a function of the linear function, the x minus 5, x plus 2, something like that. So I can use the synthetic. So let's try to refresh synthetic one more time. So you list all the constants. So this is x cubed, right? So you make yourself a note. You say, hey, this is, I started as x cubed. So I need to drop off one, when I write my answer. Oh, here you see there's no x squared. So what you need to put here is 0. And then this is 2, this is 4, right? Then you put here, this is the 7, okay? So the synthetic is, now you move the negative 1 down. Then 7 times 1 is, 7 times negative 1 is what? It's negative 7. Remember we said the synthetic is good is because you use addition. You add this together and it's a lot easier, so you don't need to worry about the negative issue. So this is negative 7, right? Okay, so now the negative 7 times negative 7. So what is negative 7 times the 7? So what will give you? Will give you negative what? 40 what? 49 here, right? So the negative 49, so you add that up, you add again, right? So it's negative 47, okay? So you add up, it's negative 47. And now negative 47 times 7, let's see here, 7 times 7, 49. So it's 329, right? So this one here is 329. So let's check here. So it's 47 times 7, so 329. So it's negative 329. Then you add them together, so it's negative 325 here. Okay, so now I got it. So what is the portions here? Remember, see how easy the synthetic is here? Okay, so the remainders here. So the remainder is the last values, right? So the remainder is what? Negative 325. And the quotient is equal to what? Because this is started at x3, right? So I drop one off. So what is this one here will be the negative x squared minus 7x minus what? Minus 47 here. Okay. Okay, so now let's take a look at the second one here. The second one, I cannot use the synthetic because the denominator is x squared. So I need to use the long division. Remember, long division is a divide, right? Okay, so let's put the long divisions here. So this is x fourth. See here, this is x fourth, right? So the highest degree is fourth. And then I don't have an x squared, so x cubed. So what I need to do, I need to save a space for that, right? So then you minus 2x squared plus 7x here. So basically you will reserve a space for the x cubed, reserve a space for the constant here. Okay, so now let's take a look. This is x squared minus x plus 3. So remember, we want to match the which term? We want to match the first terms here, right? Okay, so here this is x fourth, this is x squared. So what do we have here is x squared, right? So your x squared, this is x fourth. You times each term. X squared minus x, so this is a minus x what? Cube. X squared times 3. So what is here? 3x what? X squared, right? Then what do you need to do here? Be very careful. What you need to do, you need to minus this, right? Okay, minus here. So this is a minus out. So this is 0 minus. So minus minus will give you what? Positive x cubed. Minus 2 minus 3 will give you what? Minus 5x squared plus 7x here. Okay, now I need to match the first term again. So this is x cubed. So what I need to do here, I need to do x here, right? So x cubed. So it's x cubed. X times negative x is what? Is negative x squared. X here is what? Is 3x here, right? So don't forget for the, for the long division is minuses, right? Okay, so we need to be careful about the negative. So x3 cancel. Negative 5x minus negative x. So minus minus positive. So this one will give you minus x4 square. 7 minus 3 is plus 4x here, right? So I have this constant drop down here. This is kind of zeros, right? Okay, now I need to match here, negative 4. So here's a 4. So I match negative 4. So negative 4 times x squared is negative 4x squared. Negative 4 times negative x is what? Is positive 4x, right? Negative 4 times negative 3 is what? Is negative 12. Okay, don't forget what you need to do is here, you need to minus again. So here, minus this is all cancel. Oh, this one 0 minus 0 is 12, right? So this is, so we know the remainders here is what? Is equal to 12. And what is your quotient? So quotients here will be x squared plus x minus 4, right? So like I said, you need to know how to use the synthetic. Synthetic is a lot easier if your denominator is only like x plus something or x minus something. That would be pretty easy here. Okay, so now let's take a look at so here, let's take a look at number 3 here. A polynomial describe the end behavior. Okay, so let's take a look here. So this one's here, right? So this is like, okay, so here, first the end behavior, I need to look at the power. So here, this is x. That means it really is x to the first power, right? This is x to the first powers, right? So if you do that, so here, so it's a 4, 1, and so what is the highest powers here is what? Is the what here is x to the 4th. Then you have a negative here, so it's a negative x to the 4th. So we know if it's an even number of the power or exponents, both ends are going to go up or go down, right? Because of the leading coefficient in front of negative x4, so it's negative. So what is my end behaviors here? We say both ends but go down, right? Go downward. Okay, so my graph is supposed to be see both ends go like down like that, right? Okay, so now let's take a look at the zeros, all right? Zeros is like those things you let equal to, you let all the factors. So this is nice enough. They already factored it for you, right? So they factored it for you. So you just set each one equal to 0. So this one here is x minus 5. So 0 is at x equal to 5, right? Then this one here, this is x squared minus 9. So be careful, the x squared minus 9, you still can continue factor, will be x minus 3, x plus 3. So what is the zeros here? X equal to 3, x equal to what? Negative 3, and x equal to what? Negative 2. And because none of them have a square, so multiplicity is this one is 1, 1, 1, 1. So, okay, so what is the x-intercept? X-intercept is basically is zeros, right? Because it's y equal to 0. So basically it's 0. So I have x-intercept at x equal to 5, 3, negative 3, negative 2. Then the y-intercept basically is what? Is you set the x equal to 0. So if x equal to 0, this is negative 5, this is negative 9, this is 2. So it's negative 5 times negative 9 is positive 45, is 19 and negative. So this is the y-intercept is negative 90 here. Okay, so now based on this information, let's try to graph it, all right? So I know the end behavior, so let's try to put all the points here. 0 is 5, 1, 2, 3, 4, 5. So I have 1, 0 here, I have 1, 0 here, and I have 1, 0, negative 3, I have 1, 0 here, all right? And then because of the multiplicity is all equal to 1, so I don't have the 1 tangent at the x-axis, right? So we say the multiplicity, if it's an even number, then you cannot tangent. Then y equal to the negative 90, so it's something way down here, right? Okay, so now let's try to graph it. Of course, I cannot graph it like very precise, but I know because the both ends has to go down, right? So that means I need to start this end go down. So because this ones here, they're going to pass through here. So they're going to reach some point and then they need to come down again because they need to pass through here, right? And then they need to go all the way to touch the what? The y. So this is a terrible drawing here. Okay, so that's missing here. Okay, so they need to, this is my, so they need to come down here, passing through this 0, then go all the way to passing the y-intercept, and then they need to go through here, so they need to go up here. All right, so need to go up here to some degrees, then we're going to make a turn again, right? So because now the both end is going down here. To get that, okay? So now let's take a look at the next ones here. The next one, the end behavior, let's take a look at what is my end behaviors here. Okay, so in here, okay, so in here, this is 1s, right? But I have a 2s here. So I know that the end behavior, so this is 2, so this is 1, and this is 1, but the outside has 2, so it's 2. So 2 plus 2, and this is 5. So I know I have a degrees of the 5, and I have a degrees of the 5, and then I also have a negative sign in front of it. So we know the odd degree, and that means 1 go up, 1 go down. So I have a negative sign with degrees of what? So it's x to the 5th, right? So I know the negative sign will go to, so what is the in here? So you know your left end go up and the right end go down, right? We know that if leading coefficient is positive, then my right end will go up, left end and go down. Okay, so the zeros here is the same thing. You set the equal, right? So you set it equal to 0 and solve it. So in here, I will say this one is equal to 1, this is equal to 4, this is equal to negative 2. Okay, so I have a 0 is 1, 4, and negative 2. So this is 1, but I have a square. So what is the multiplicity here? Multiplicity is 2, right? So this is x4, so multiplicity is 1. This is x plus 2, so x equal to negative 2, but I have a squares here, so multiplicity is what? Is 2 here, okay? So my x-intercept is the same, is x equal to 1, x equal to 4, and the x equal to the negative 2 here. Then the y-intercept is like, I will let the x equal to 0. Okay, so let's see here, what is my y-intercept? Y-intercept x equal to 0, so this is negative 1 to the square times negative 4, this is 2 to the square. So this is a positive, this is negative, negative, positive. So 16, all right? So the y-intercept is 16 here. Okay, so now let's try to plot that. Okay, so here, let me try to make the scale a little bit bigger so it's easy. So 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. It's 1, 2, 3, 4, 5. Okay, so first let's mark where is our x-intercept, right? So x-intercept at 1, at 4, and negative 2 here. And the y-intercept is 16, so it's somewhere way up there, all right? And I know my left end need to go up, and my my right end need to go down, okay? So here, right, so because this is multiplicities, right? So let me mark the multiplicities here. It's a different, let me highlight here. So like this one is a multiplicity, and then this one is a multiplicity. So we know you need to tangent that. So first leg going up, so the left leg going up, so it's something graph like this, right? Okay, so try to graph it, it's very difficult. So it's like here you go up. Because this is a multiplicity at 2, so you have to tangent that, right? So you have to tangent that. So then you go like, you tangent here, then you go all the way up here, and then in here, okay, then in here, you kind of, let me put this y intercept, don't be that high. So like here, show you. Okay, so let's see here. If my y-intercept is 16 somewhere here, so my graph is somewhere going come down and then go boom, touch the y-intercept and then going here. And this one's here, this is a multiplicity of the 2. So I know I cannot go through the x-axis, so I need to kind of a tangent turn again, right? So I need to turn again to some kind of the curve here. Then I need to go through here because my end behavior tell me, right? So by end behavior tell me, I need to go through, and because my right end going to go down here. So this will be my graph, roughly will be my graph. Okay, so now, okay, that's good. And so the next thing here, we're going to talk about find the quadratic function, find the vertex here. And like we say, you can do whatever you feel more comfortable. You can either use the complete square or use the formula I gave you before. So it's like, the vertex, the x coordinates will be negative b over what? Negative b over 2a here, right? Okay, so that will be a lot easier instead of a complete square. So let's see here, this is 1x squared, 6x plus 2. So the a is 1, b is 6, and C is what? Is 2, right? So the vertex here, the x coordinates will be negative b, so it's negative 6 over 2 times a, so it's 2, so it's negative 3. So I got it, right? So I say, hey, this is negative 3. So what is the y coordinates? Y coordinates will just be you plug the negative 3, you just get into your function. So this will be the negative 3, the square, plus 6, the negative 3, plus 2. Okay, so if you calculate that, so this is will be 9 minus 18 plus 2, so it's negative 7. Okay, so that is how I get the, here is negative 7. All right, so that's how do I get the vertex. Like I said, you can always, all right, you can always use the completed square. Okay, now the next thing here is x-intercept. X-intercept is you set the y equal to 0. So this is 6x plus 2. You set it is equal to 0, right? Now, obviously, this one's here is not easy to factor. I cannot factor. So I have to use what? I have to use quadratic formulas here. So x will be equal to 2a, so it's 2 minus b plus or minus the square roots of the b square. So 6 squared is 36 minus 4ac. So minus 4 times 1 times 2. Okay, so now if you simplify this a little bit, and you will get, you know, the, okay, so here you will find out this will be the negative 3 plus the square roots of the 7 plus or minus the square roots of the 7th here. So if you plug into your calculator, one number will be pretty close to negative 0.354, and the other ones here will be the negative very close to, and negative 5.646. So my x-intercept will be the negative 0.354, and I have negative 5.640 here, right? So this is kind of like you want to find the x-intercept by using the quadratic formula. Okay, so now the next thing here, the y-intercept. The y-intercept is pretty easy. Basically, you just let the x equal to 0. X equal to 0, so this is 0, 0. So what is here? It's 2, right? Okay, so now other one they want you to find is local max and the local min. Here, because here is positives, right? So I know what is my graph going to look like. My graph going to open upward because this constant 1 is positive. If I open upward, so what I have here, I have a local what? Local means, right? So you need to say the local mean is equal to. So what is this? This is a vertex y value. So hey, I already got it. So it's negative 7. So that's why the minimum value is negative 7. Okay, so let's take a look at another one. Let's do it one more time, right? So I really feel like use the x equal to negative b over 2a is a little easier than to complete the square because a lot of times students get confused, right? So first things, let's write down what is a. A is negative 2, b is what? B is 12, c is equal to what? C equal to 0, right? So the vertex, right? So the x here is equal to 2a, so it's negative 4. Negative b is negative 12. So what is here? Is 3, right? Okay, so I know my vertex here, the first number is 3. Okay, after that, remember you just plug the 3 back to your function to get a y value. So 3 here, you will say negative 2, the 3 to the square plus 12 times 3. So negative 18 plus 36. So what is here is 18 here. Very good, right? So now I know my vertex here is 18. So this is the 18th here. Okay, so now let's take a look at the x-intercept. The x-intercept is set equal to 0 and solve for the x. So I have a 2x squared plus 12x. That means set equal to 0. I can factor. I can take a negative 2x out. So what is the first term? X. I take a negative 2 out. What is here? Negative 6 equal what? Equal to 0, right? So if this equal to 0, I set this one equal to 0, this one equal to 0, and I solve it. So what do you have here? I have x equal to 0, x equal to 6. So my x-intercept will be 0, 0, and 6 zeros here. Okay, the y-intercept here. The y-intercept is x equal to 0. So this will be 0, this will be 0, right? So y-intercept is 0. There's 0 over 0. So I should say this is 2 here. Okay, so now let's take a look at these ones here. Because I have the constants here is negative, so I know my graph is what? My graph is open down. If your graph is open down, so what is this value here? This is the maximum values, right? So now I know for this problem I have a maximum value. And what is this maximum value? This maximum value is the value of your y value in the vertex. So it's max equal to 18 here. Okay, and that's it. All right. So this is our first video, and we finished the first 4 problems here, and then we're going to have our next video to finish the remaining 4 problems. Okay, that's it. Okay, talk to you later. All right, bye.